The Ford Transit that I purchased includes 2 alternators and 2 AGM batteries that are the van batteries, essentially. With that addition, the Ford Transit has 2 connection points for getting DC out of the back into the back of the van to be used for myself, for my camping and that kind of thing. And one of the connections is called CCP1, and that one is a 60 amp. It's rated at 60 amps at 12 volts, and that is continuous. So you can use it all the time, and I guess it'll disable itself automatically if the batteries become low. And then the second one is the additional one, the CCP2 connector, is added with the package that I had added to the Ford Transit. It's called the RV Prep Package, and it includes a second customer connection for DC, and that one is rated at 175 amps for 12 volts, and it's only enabled when the ignition key is on. Because I have 2 alternators, I'm able to use up to 175 watts, but of course I wouldn't use that much, but up to 175 watts off of that connection. So my plan, and I have no idea if this is going to work, but I'm hoping it'll work, is that I'm going to use that 175 amp connection. I'm going to put a 150 amp circuit breaker on it, DC circuit breaker, and then I'm going to connect it into this monstrous inverter from Renogy, 2000 watt inverter. I'm not going to use 2000 watts, but 1500 watts maybe. We'll see how it goes. I'm going to put it into this inverter, and then the AC out of this inverter, I'm going to run into my Bluetti AC200L battery. Now you ask, why would I go from DC to AC to DC into a battery? Isn't that wasting a lot? And yes, it is wasting a lot of electricity. But here's the thing. The AC200L really has 2 inputs of power, and it can use both of those inputs at the same time or at any time. And if you want to use like the Charger 1 from Bluetti, the only way that Charger 1 can come into your Bluetti 200L is through the solar input, which means you have to disconnect your solar and reconnect the Charger 1, or you have to find a way to auto switch them, or you need another controller to control that. And then it's only rated at 560 watts. So you can only get 560 watts out of the Charger 1. And you can't have them both at the same time. You can't have your solar and the Charger 1 at the same time. There's no real good way to do that unless you perfectly match the voltage and then put them in parallel. But that's not really an option for me. So with this, I can have actually the AC path into the Bluetti AC 200L. I can actually have the AC path charging, while at the same time, if I have solar panels, they can be pulling and charge as well. And I can get up to 2400 watts at the same time using the combined. In fact, that particular Bluetti can actually charge AC at 2400 watts, which means it can charge almost the whole battery in a little more than an hour if you did it at full wattage. I wouldn't do that at full wattage. I'll probably do it at maybe half that, maybe 1200, 1400, somewhere around there watts I'm going to be pulling out of this. So while I'm driving, I'll be able to charge that battery with just the alternator output very quickly. And so for that reason, I'm probably going to forego putting solar panels on my roof initially, because it's a very scary thing getting up on the roof and drilling holes in the roof and that kind of thing. So I'm putting that off till later. And I am hoping that this method will allow me to keep my batteries, my in-house, my cabin, my camper batteries topped off, my Bluetti. I'm hoping I can keep my Bluetti battery topped off using this method from the alternators, just by driving maybe a half hour a day average. So I am wiring up this Renogy 2000 watt pure sine wave inverter, and it has this little plastic thing. So this was actually on here when I and you just squeeze these little tabs, it pops off. And then I took the cable that came with the Renogy, and I threaded it. I took the bolt out that was on this lug, and I threaded it through their cable. And that little tab that sticks out, it seems to be threaded, or if it's not threaded, it sure helps to turn it to go in. And then there's a nut that goes on the bottom, and you turn that. And you know what? I think you can just tighten this with a screwdriver. Ooh, try to get it actually straight. And you know what? I did it. This is the second time I've done this. So the reason I took it off before I started explaining it and making the same mistake is you actually want this plastic thing to protect the connection. So you need to put the plus side up. You need to put the plus side, you need to put this on the cable, because there's no good way to thread it on after unless you come from the other end, I guess. And then put the cable on. Uh-oh. Okay. And then straighten it out. Tight. And then you can put this right back on. Oh, wait. There. It's not that great, is it? There we go. I'll put that on one more time just so you get the idea. So I don't know if any of that was visible. I'll do the negative terminal now, complete, so you get the real idea. Take off the terminal cover, thread it onto the cable. You remove the screw, the bolt. Try not to lose the washer and lock washer that are there. And I don't know if I'm doing it right, but you put the lug directly on the tab, and you thread the bolt back into the hole, and if you turn it, it will screw through the hole. So it's not, I don't know if the hole is threaded, but it certainly helps to turn it. And so you like put the nut on, and you tighten up the top, keep it straight, tight, and then you take the plastic cap and put it the right way with a negative on top, and it just goes back in. There you go. So do the exact same thing for the positive terminal, which I already did, and now I have two connections that are fairly well connected. I mean, if you really tried really hard, I guess you could try to find a way to touch both of these. It'd be pretty difficult though. So it's fairly secure. So now for wiring the circuit breaker that I bought. This is a DC circuit breaker, 150 amps. It's currently open right now. What am I doing? I need so you wire it to the positive side. And it's really hard to see, but in really fine print it says load, and then down here it says bat. So load goes, in my case, the inverter is the load, and the battery is going to be the customer, the CCP 2 connector on the Ford Transit. So I am going to put this circuit breaker in line so that if for some reason this inverter decides to take more than 150 amps, I want this breaker to pop. And the reason is because there's a 175 amp fuse inside the Ford Transit under the seat. And it's my understanding is that fuse is a blow fuse. And not only that, it's in a very difficult place to get to. So I would rather not have to try to figure out how to replace that fuse. So I am hoping the circuit breaker will protect me from that fuse having to blow. I think it's important to record my mistakes. So I bought this extra cable from another company. And if you look, the lug it's kind of bigger than the one that came with the Reno-G, which fit nicely on here. But this one, there is no place that is skinny enough. As far as I can tell, there is no place that is skinny enough for this to fit over the nut. I mean, over the bolt. So I'm not exactly sure what I'm going to do here yet. Well, there's two options. I could try to find another cable, or I could possibly file this just to make it's so close, just a little thinner so that I can actually get it on there. That's probably what I'm going to do here. Okay, I don't know if this is a good idea, but at least it will be captured on film. So, you know, if it kills me, it'll go on YouTube or TikTok, and people know not to do it. There's a Dremel. Oh, I'm going to say don't do it that way. Okay, option 2 is I just make the whole hole bigger. Let me see. Nope. I don't know what that's going to do, to be honest. I can't make it that much bigger. Okay, so that's not going to work. Oh, crap. So, back to my original idea. I don't really have any round files. I got this triangle, but you know what? I just have to flatten this top. Actually, now that I think about this, diamond disc. I don't have to make the hole bigger. I just have to make this rounded edge a little shorter so that I can put it on this way. So I don't know if that's making any dent at all. Let me see. Oh, yeah, it is. It's getting shorter. Good idea to let these things cool off sometimes, because they get incredibly hot on metal on metal. Let's give that a try after it cools off. I don't know if I can get this in focus. Oh, you can't see it. See that edge? It's flattened off the top. All right, let's try this again. Oh, look at that. Goes on. And I believe that's going to be a good enough connection, I hope. Let's tighten her up. I hope. Maybe I should use a bigger washer. I don't know. That is not going. It's not going anywhere. I want to make sure, because if this ever goes on the road, like with this connection, it's, you know what? It's a little loose. I want to see if I can find a washer for it. Okay, so let's try that again. Put that on. The washer has the same problem. That's hilarious. All right, we're gonna try this guy. Oh, it's a little small, skinnier washer, but it's still, I think, a better adapter than that big open hole. And I should be using a socket for this instead of a crescent wrench, but it was there. And I think it's okay. Although a socket would be a lot easier. I just have to find the right socket, and it takes forever. Oops. It sure is easier to use a socket. That's pretty tight. Okay, so that is not going anywhere. And this, also good. So now I have two terminals that can now go directly to the CCP2 connector on the Ford Transit. And through a circuit breaker here, which I can reset. And in this load, in the Renogy 2000 watt, we'll be able to provide AC output. And I can test that without my battery by just plugging in some other AC device just to see if it works okay. And maybe I'll do that. What the hell? So right down here is CCP1, and that's CCP2, and I believe that was the ground wire up there. This is on a Ford 2025 Transit. All right, this is looking at the CCP connection point, customer connection point on the Ford Transit 2025. I am going to first, you can't really see this and it's impossible to camera in there, but the ground terminal is the top one, and there is a nut that's on it. And if I can get this on there, I'm gonna take that nut off because across the 16 amp terminal at the top with this ground next to it. It's okay. You know what? I can't. What do I do? I can get that on my fingers. I have to use the whole way. Which is quite annoying. Oh, very last part. Yay! Okay, so at least they put the non-continuous one next to the ground so that if you do accidentally touch both, you don't electrocute yourself. Wouldn't kill me probably, but I don't want to find out. All right, so we're gonna go with the positive. Actually, I need to find a nut that fits the positive terminal. Is my first guess gonna work? Almost. Almost. Oh, Ford loves M8s. Let's try an M8. Sorry about the delay here. Let's try an M8 nut. Because Ford loves M8s. Yes, that's it. Okay. Keep that in mind. When in doubt, you hear that? When in doubt, use an M8. Alright, so we're going to put the positive terminal on the non-contiguous CCP2. And tighten her up because you need a good connection. Even for a test like this, where we're testing electrical, you still want a good connection, so you don't want to do this with like a loose connection because you do not want arcing. Arcing is when you've got a gap between two conductive surfaces and it is just close enough that the electricity can jump across the gap, which produces like a spark. If you've ever experienced static electricity, you've probably experienced arcing, just a different kind of force. I used to work somewhere. Uh-oh, did I put that? Oh my God, I think I threw the nut into my box for the ground. That's awesome, isn't it? Let's hope it's one of these M numbers. It might be. It's not M8. Let's try. No, it's not M8, so let's try M6. Or I'm gonna have to go search. Oh my God, it is M6, and that actually fits better. Weird, huh? So now I'm gonna connect the ground terminal, which hopefully will not touch the positive terminal, or I'm gonna have real fun. I really don't like, these things are way too close to each other. Ford, these are too close, you know? That is not a great idea. I mean, yeah, once I lock it down, it should be okay, but I don't like the fact that this could get shorted out pretty easily. Where'd my wrench go? Oh, there it is. So we got M8 on the positive terminal, and we got M6 on the negative terminal. And I cannot get my wrench. Oh, because, yep, there's no way. I need these sockets for this. Why am I using press sensors? I don't know. It's too lazy to get all my sockets set. Figure out which size this is for one nut, but I will tell you it will save me a great deal of time at this point. Oh man, I can't see like that. Alright, that's tight enough. Let's take a look at that with the camera close. Make sure there is a gap between, it's really out of focus, sorry, but I just want to make sure there's a gap between those two terminals, which I do see, because otherwise when I turn this on, we're gonna get sparks. I really don't like this. It's not a well designed. As I never was an electrician person, I don't like the design of it that much. Okay, so now we've got negative, positive terminals hooked up. I've got a circuit breaker on the positive going into the inverter, and then the inverter negative going directly to the ground terminal on the CCP connection. All right, so for this test, I've got a Bluetti battery. I have the Bluetti charger. I have the inverter, and I have the circuit breaker. So what I'm going to do is I'm going to connect the Bluetti charger. This is just a test. Make sure my ideas are right, that this is going to work. I'm going to plug in the, actually I'm not going to plug in the Bluetti, I'm not going to plug in the load just yet. So far the load is just going to be this 2000 watt inverter, which is actually shut off right now. Switch on the back, so it's currently turned off. So I'm going to turn on the engine and hope nothing bad happens. It's actually the worst part, scariest part. So, turn on the engine. Let's go ahead and watch me. I don't know if you can see this, but let's turn on the engine. Okay, nothing bad happened so far. Okay, so back to my inverter and battery. I'm going to, first step, actually, I already know I have power. I am going to flip the circuit, turn on the circuit breaker, and hope nothing bad happens. Oh. Okay, that should be providing power to the inverter on the DC side. okay. The next step is to turn the inverter on. This is where I actually put load. So I turned on it beeped. That means there's power. And interestingly, the Bluetti charger, even though it's not currently plugged into the Bluetti, does have a light on because it is receiving power because it was plugged in. It's not drawing much load yet. So what I'll do next is I will plug this into the Bluetti itself. I should do that again. So I will plug this into the Bluetti, but the problem right now is my Bluetti has 100% charge. So let's see. Okay, so it's pulling 170 watts, 185. I know it'll pull up to 200. So I am currently pulling almost 200 watts through the inverter, through the charger, to the Bluetti, all from the CCP 2 connection point, which is only enabled when the car and when the van is turned on. So I consider this test to be a success. In the real final scenario, I'm going to be, so far my current plan is to use my Bluetti AC200L because that allows charging at a much higher wattage. I believe it's, for AC charging you can go up to 2400 watts. I'm not going to go that high because it'll blow circuits, but I am planning to use perhaps 1200 watts to charge the AC200, and I can't wait to try that. But right now that battery is in the back of my minivan, and without taking the minivan apart I can't get the battery out, and it weighs 60 pounds. So that'll come later. I got to do my floors first anyways. This was just a test to make sure it's feasible and to make sure I don't need to prioritize solar, and I don't think I do, because I think I'll be able to keep topped up just based on this very simple solution. Anyway, so this test was a resounding success. I can't wait to get a floor in and start building cabinetry so I can actually bring my large battery in here and connect this thing all up. I was surprised about the size of the 2000 watt Renogy inverter. It is actually bigger than my old battery, so it's ginormous. I don't know how much of that has to do with heat dissipation. There's a bunch of fans on it, things like that. I do have to make sure it's not crowded and there's good ventilation for it, because I do understand they generate a lot of heat. But this is looking good. I think with only an average of a half hour of driving a day, I'll have enough power for what I typically use, even for electric heating, or electric cooking. Electric heating is definitely out. I may add on to my AC200L an expansion battery to give me more flexibility on how often I drive. So if I were to drive only once every 5 days, but say 4 hours, then I want to make sure that's covered, and I may need more battery capacity for that. Not more charging power, but more capacity, so that my driving is actually spaced out more, and I don't need to drive like every few days, an hour every few days, which I may have to do with a single AC200L. But we'll see how it goes when I finally get on the road. I think it'll be okay. I hope so, because I'm not planning on putting on solar panels up before Alaska. So I'm probably, at this juncture, my current plan is to completely run off this inverter and the CCP2 connector on the Transit. Anyways, Van Wander.